Good afternoon, class. We are looking at section 2 of trigonometric functions, unit circle, uh, 5.2 unit circle. So we covered angles and their measures. Now trigonometric functions, unit circle approach, and properties of the trigonometric functions. Here's the objectives for this section. Find the exact values of trig functions using a point on the unit circle. Find the exact values of trig functions of quadrantal angles. Find the exact values of trig functions for pi over 4 or 45 degrees, pi over 6 or 30 degrees, pi over 6, pi over 3 or 60 degrees. Find the exact value of trig functions for integer multiples of those angles. Use a calculator to approximate the value of a trig function. Use a circle of radius r to find trig functions. So that's what we are going to cover right here in this section. All right, so let's remind everybody of what we covered already. Vertex, line, ray, initial side, terminal side, positive angles, or counterclockwise, negative angles, or clockwise, standard position, quadrantal angles, right angle, straight angle, and so on. So you have a line here that it goes indefinitely on both sides. This is the vertex, and this is considered a portion of a line or even half line. So we have the initial side along the positive side of the x-axis, and that creates the standard position. So here's the vertex, here's the initial side, here's the terminals. Again, counterclockwise, positive, clockwise, negative angle. Standard position, initial side is along the positive side of the x-axis. The vertex is at the origin. So these two angles are in standard position. This one is positive because it's going counterclockwise. This one is negative because it's going clockwise. Now, theta is a quadrantal angle as long as the terminal side is along the positive or negative side of the x-axis, the positive or negative side of the y-axis. In this case, the terminal side is along the negative side of the y-axis, giving us 270 degrees. If you go a complete revolution, one revolution counterclockwise is 360 degrees. Right angle, 1/4 of a revolution counterclockwise, 90 degrees. Straight angle, half of the revolution counterclockwise. The relationship between degrees and radians, d over 180 is r over pi. 1 degree is 60 minutes. 1 minute is 60 seconds. And we have the arc length S equals r theta. The area of the sector, a portion of a circle, is 1/2 r squared theta. Angular speed, omega, theta over t, or 2 pi times r, p, m, or s. This last one, m, is minutes, could be seconds, could be hours, units of time. Linear speed, v is s over t, which becomes r omega. So this is the synopsis of what we've learned. And now, a circle of radius r located with the center at 0, 0 as the equation x squared plus y squared equals r squared. When r is 1, it gives rise to what we call a unit circle. So therefore, when we look at this, This point must have 1, 0 as coordinates, 0, 1, negative 1, 0, 0, negative 1. P is a point with coordinates x comma y. S is the arc of t units. Let t be a real number and let p equals x comma y be the point on the unit circle that corresponds to t. Of course, it's going counterclockwise and positive here. Over here is clockwise and negative. We put in absolute value. So now what happens? Again, reminding you of the equation of a circle. X squared plus y squared equals r squared. X minus h quantity squared plus y minus k quantity squared equals r squared. So in the case of a unit circle, x squared plus y squared is 1. A point has coordinates x comma y, and we define y as sine and cosine as x. Let t be a real number and let p with coordinates x comma y be the point on a unit circle that corresponds to t. Look at what happens here. This point has coordinates x comma y. This point has coordinates x, which is equal to cosine t, and has coordinate y, which is equal to the sine t. And we're going to go over the justification for that in a moment. The sine function associates with t the y coordinate of p and is denoted by sine t equals y. The cosine function associates with t the x coordinate of p and is denoted by cosine t equals x. Here's the reason. If you recall the definition of a sine was opposite over the hypotenuse. So if you look at this angle t or theta, sine is the opposite, which is sine t, which is the distance y, over the hypotenuse. The hypotenuse is 1. So y over 1, therefore y becomes sine t. On the other hand, over here, cosine is the adjacent, this distance, which is x, over the hypotenuse. The hypotenuse is 1 because it's a unit circle, therefore it becomes adjacent over 1. So it becomes cosine, and we say cosine t equals x. That's the justification for that. So pretty straightforward. If x is not equal to 0, the tangent function associates with t the ratio of the y coordinate to the x coordinate of p and is denoted by tangent is y over x. Remember, tangent is sine over cosine. And the rest of them follow. Tangent is y over x or sine over cosine. Cotangent is the reciprocal of that, x over y or cosine over sine. Cosecant is 1 over sine, which makes it 1 over y, and secant is 1 over cosine, which makes it 1 over x. Needless to say, in all cases, the denominator can't be 0, so we're going to be careful with that. Find the exact values of all trig functions if P, the point P has the coordinates -1/2 square root of 3/2, is a point on a unit circle. And again, reminding you of what we have here, a quick reminder. X squared plus y squared equals 1. That's a unit circle. P has coordinates x comma y or cosine t sine t, where sine t is y, cosine t is x, and the rest of trigonometric functions are defined as such. Tangent is y over x, cotangent is x over y, cosecant is 1 over y, secant is 1 over x. In short, we find cosine, sine, and tangent, and the rest of them are the reciprocal, everybody. So we draw a unit circle and we locate this pair. And this is the x. And this is the y. So this is the x, -1/2, that means cosine. This is the y, square root of 3 over 2, that means the sine. So we write sine t is equal to the y coordinate, which is square root of 3 over 2. Cosine t equals to x coordinate, which is equal to -1. Tangent is sine over cosine or y over x, however we want to think about it. Tangent is sine over cosine or y over x. So that means this one over this one. It's a complex fraction. The denominators to cancel each other. We get negative square root of 3. The rest of them, just go back to them and write the reciprocal. For this one, the reciprocal is 2 over square root of 3. That becomes cosecant. For this one, the reciprocal is -2. For this one, the reciprocal is 1 over negative square root of 3. And I want to show you a couple of things here. This one class, the reciprocal is 2 over square root of 3. So you multiply by square root of 3 over square root of 3 to rationalize. This one, the reciprocal is -1 over square root of 3. You multiply it by square root of 3 over square root of 3 to rationalize. Very straightforward. A quick recap. We are given a pair on a unit circle. The x gives us the cosine, the y gives us the sine, and when we have cosine and sine, we can find the rest of them. Tangent is the ratio of sine to cosine. The rest of them are reciprocals of those three trigonometric functions. Find the exact values of the trig functions of quadrantal angles. Remember, quadrantal angles, the terminal side is along the positive or negative side of the x or y axis. So for example, theta equals 0, looks like this. So when theta is equal to 0, the point here has coordinates 1, comma 0. So 1 is cosine, 0 is sine. So sine of 0 degrees is 0, cosine of 0 degrees is 1. Tangent is y over x. Y is 0, x is 1. 0 over 1 gives you 0. Cotangent is the reciprocal, which is undefined. Cosecant is the reciprocal of sine, undefined. Secant, reciprocal of cosine, 1 over 1 is 1. Pi over 2. That means right here. By the way, pi over 2 are 90 degrees. Coordinates 0, comma 1. So if x is 0, that means cosine of pi over 2 is 0. If y is 1, that means sine of pi over 2 must be 1. So knowing those quadrantal angles are truly helpful. So tangent is sine over cosine, because cosine is 0, becomes undefined. Cotangent is the reciprocal of that, cosine over sine, which is 0. Cosecant of a pi over 2, cosecant is 1 over sine. So 1 over 1 is 1. And secant is 1 over cosine, undefined. By the way, UD short for undefined, everybody. So again, knowing the coordinates makes it easy to find the answer. So here's another one. Theta equals pi ends up here, pi or 180 degrees. And you know the coordinates are negative 1, comma 0. Therefore, if x is negative 1, cosine must be negative 1. If y is 0, sine must be 0. Tangent is sine over cosine becomes 0, cotangent becomes undefined. Cosecant is 1 over sine, undefined. Secant, 1 over negative 1 is negative 1. So those are common arcs. We should know the value, and it's easily calculated. Now this guy, 3 pi over 2 or 270 degrees, lands right here. And over here, the coordinates 0, comma, negative 1. Which means the x coordinate is 0. That means cosine of 3 pi over 2 or 270 degrees must be 0. Y is negative 1. That means sine of 3 pi over 2 or 270 degrees must be negative 1. And the rest follow. This is tangent is sine over cosine. Cosine is 0, makes it undefined. Cotangent is the reciprocal, makes it 0. Cosecant. Cosecant is 1 over sine. So the reciprocal of that is negative 1. And secant is undefined. So again, knowing these values make it very easy to see the answer, everybody. Those are among the common arcs we should be familiar with everybody. Definition. If theta equals t radians, the six trigonometric functions of the angle theta are defined as sine theta is the same as sine t, cosine theta equals cosine t, and the rest of it. So you use t or theta. That's the idea behind that. Normally, theta represents an angle, t represents an arc. They are interchangeable. And so theta radians or theta equals t radians. In this case, t is negative. And these are what we just went over, the quadrantal angles, 0 degrees, power 2, 3 power 2. And again, as long as you remember what we just went over, this is, for example, 1, 0, which clearly indicates cosine of 0 is 1, sine of 0 is 0. So this is the best way to remember the entire table. It's part of common arcs we should be familiar with. Find the exact values of the trig functions that are multiples of quadrantal angles. Bear in mind x comma y, that means cosine t comma sine t. So we want sine of 3 pi. So remember the meaning of 3 pi. So it's 2 pi plus pi. You go a complete revolution and you land at pi. So a complete revolution and you land at pi. You know the coordinates are negative 1, 0. And because the y coordinate is the sine, so sine must be 0. Sine of 3 pi must be 0. In fact, cosine must be negative. Now, negative 270 degrees. So you go this way and you end up here. And here, you know the coordinates are 0, comma 1. So x is 0, y is 1, cosine is x. The answer is 0. So cosine equals x, and therefore 0. For the sake of argument, sine of negative 270 would be positive 1. Let's just write that. Sine of negative 270 degrees must be positive 1. And of course, there are other ways to deal with negative. Later on, we'll discuss that. Find the exact values of the trig functions. Specifically, we are looking for 45 degrees, everybody. Pi over 4 or 45 degrees. So what's missing underneath of pi over 4 or 45 degrees? And we're going to go with the unit circle, 45 degrees. Looks like that. And it's important to know that this point is on the unit circle. So x squared plus y squared equals 1. Now, because it's 45 degrees, this line has the equation y equals x. So if x equals y, all you have to do, replace the y with x. So y is equal to x. You're going to say x squared plus x squared. That means 2x squared equals 1. Of course, x and y are both positive because we are in the first quadrant. So if that's the case, this gives us 2x squared equals 1. X squared is 1/2. X is plus minus square root of 1/2. And we've already decided they are positive. So X is equal to positive 1 over square root of 2. The 1 comes out. You can rationalize by multiplying by square root of 2 over square root of 2. You know the y coordinate is the same. Therefore, the point has coordinates square root of 2 over 2 for the x as well as the y. So this is the point with coordinates square root of 2 over 2. And so if that is the case, sine and cosine are identical for pi over 4 or 45 degrees. They are both square root of 2 over 2. Again, it's important to know that P lies on the unit circle as well as y equals x, because this is 45 degrees plus. So is this one. If this is 45 degrees, so is this one. Okay. And that's why it's the line y equals x. Now, what is tangent? Y over x becomes 1. Tangent and cotangent are both equal to 1. Now, cosecant is 1 over this. So 2 over square root of 2, the same thing as secant, 2 over square root of 2. Both of them become square root of 2. Let me show you that. So the reciprocal of this number is 2 over square root of 2. And if you multiply by square root of 2 over square root of 2, you get 2 square root of 2 over 2. And that's the answer. Now, again, at the very least, you want to memorize these 3, I would say, or at least these 2. You can figure out the rest easily. Sine and cosine are square root of 2 over 2. The rest of them, you know, trigonometric identities. Tangent is sine over cosine. Cotangent is cosine over sine. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And you can figure it out that way. That goes pretty fast. Now, let's find the exact values of trigonometric expression sine times tan. Sine of 45 degrees times tan of 45 degrees. And we should know this, right? Sine, square root of 2 over 2. Tangent, 1. Their product must be square root of 2 over 2. The next trigonometric expression, secant of pi over 4, cotangent of pi over 4. And again, if you don't remember them from secant, okay, how do you get to secant? Secant is 1 over cosine. You can go that route. In this case, I'll put the numbers here. But remember, this is the reciprocal of this number, which makes it square root of 2. This is the reciprocal of this number, which makes it 1. So it's square root of 2 times 1. Sine of 45 times cosine of 180. Sine of 45, square root of 2 over 2. Cosine of 180, negative 1. So those are common arcs we should know. So minus square root of 2 over 2. Tan of pi over 4 minus sine of 3 pi over 2. Tangent is 1. Sine is negative 1. So 1 minus negative 1, which means 1 plus 1. And it's equal to 2. Again, common arcs. We should know the trigonometric functional values. Secant of pi over 4 quantity squared plus cosecant of power 2 quantity squared. And again, if you don't remember it, you can go to sine and cosine. In this case, 1 over cosine. In this case, 1 over sine. So, and therefore, we know that this one is square root of 2. We raise it to the power of 2. Cosecant is 1 over sine. Remember, sine of power 2 is 1. If sine of power 2 is 1, cosecant is the reciprocal of that, makes it also 1. Now this one is square root of 2 squared is 2 plus 1 was 3. It's pretty straightforward. You should know all the common arcs and their values. Trigonometric functional values. Okay, let's remind everybody of the following. A triangle is a specific type of polygon having only 3 sides and 3 angles. The angle sum property of triangle. The sum of all interior angles of a triangle will always add up to 180 degrees. What types do we have? Types of triangles with respect to the length of the sides. Scalene triangle, all sides and angles have different measures. Isosceles triangle has 2 equal sides and 2 equal angles. Equilateral triangles, all sides and angles must be equal. That means 180 divided by 3, that means 60 degrees. So this one, scalene, this one, isosceles, 2 sides are equal, 2 angles are equal. This one, all sides and angles must be identical. Now, types of triangles with respect to the angles. Right angle triangle, one of the 3 interior angles has a measure of 90 degrees. Acute angle triangle, all the 3 interior angles are acute, that means less than 90 degrees. Obtuse angle triangle, one of the 3 interior angles is an obtuse angle, has a measure greater than 90 degrees. For example, this is a 90 degree for a right triangle. This one, each and every one of them is less than 90 degrees. This one of them is larger than 90 degrees. By the way, of course, we can't have more than one to be 90 or larger than 90 degrees because the sum must be 180 degrees. So it's pretty straightforward. Find the exact values of the trigonometric functions of pi over 6 or 30 degrees and pi over 3 or 60 degrees given the right triangle of hypotenuse 1 below, find the mix. So we can use this idea to handle the answer. So we have a right triangle. This side is 1. This angle is given as 60 degrees. This angle is also given as 30 degrees. So we want to work with them. So one angle is pi over 6 or 30 degrees. And the other one, of course, 90 minus that must be over 3 or 60 degrees. Let's make an identical triangle and put it next to it. Make a second congruent triangle. Put them next to it. So if you do that, this is 1. This is identical to that, must be 1. This is identical to this. If this is A, this must be A. This is in common. This angle was 30 degrees, so this must be 30 degrees. This was 60, so this must be 60 degrees. As you can see, all sides are given here. This is 1, this is 1. All, this is missing, we're going to work on it. All angles, this is 60 degrees for the big one. This is 60 degrees. This is 60 degrees. This triangle is equilateral, so all sides are 1. Therefore, 2a equals 1 and a equals 1/2. Why is that equilateral? Because all angles are 60 degrees. And if this is 1, this is 1, this becomes 1, a and a is 1. That means 2a is 1, a becomes 1/2. Now we're going to use Pythagorean theorem to find the missing height, or b in this case. We know a squared plus b squared equals c squared. So a squared is 1/4, b squared we have no idea, and c squared is also 1. So a squared plus b squared equals c squared. A is 1/2, becomes 1/4. B squared, 1 squared is also 1. So if I subtract 1/4 from both sides, this becomes 3/4. If b squared is 3/4, b is the square root of that. So this means b is square root of 3/4, which is square root of 3/2. Pretty much we have the answer. So when you find the exact values of a trigonometric function, specifically right now for power 3 or 60 degrees, and we had this, we're going to put it here. So A is 1/2, hypotenuse is 1, which becomes the radius of a unit circle, and opposite 60 degrees square root of 3/2. Therefore, this point with coordinates x being 1/2, y being square root of 3/2, where x represents the cosine, y represents the sine. Therefore, sine of power 3 or sine of 60 degrees must be square root of 3/2, where cosine must be 1/2, cosine of 60 degrees or power 3. So we have those two, we can find the rest of it. What is tangent? Sine over cosine. So if I divide this one by this one, the denominators are 2 and they cancel each other, I get square root of 3. The rest of it are reciprocals. So I want cosecant is 1 over sine. So the reciprocal of this, 2 over square root of 3. I get 2 square root of 3 over 3. Okay. Again, as long as we have the sine, we can find cosecant. As long as we have cosine, we can have secant. Secant of pi over 3 or secant of 60 degrees is the reciprocal of this number, 2 over 1. 2. Cotangent is the reciprocal of this number, 1 over square root of 3, and if I rationalize it, I get square root of 3 over 3. So, for 60 degrees, sine is square root of 3 over 2, cosine is 1/2, tangent is square root of 3, and the rest of them are reciprocals. What about pi over 6 or 30 degrees? We want to find the exact values of the trigonometric functions of pi over 6 or 30 degrees. We do exactly the same thing. We use this one, but this time we put it in this format, 30 degrees. Opposite the 30 degrees is 1/2. Adjacent is square root of 3 over 2. And if you put that using the unit circle, this x coordinate now is square root of 3 over 2, and the y coordinate is 1/2. Therefore, this one is sine, x is cosine of power 6, power 6 or 30 degrees, and y is sine. So sine is 1/2, sine of power 6 or sine of 30 degrees. Cosine is the x coordinate, square root of 3 halves. So again, cosine of power 6 or 30 degrees. The rest just follow the formula, sine over cosine. If I divide this one by this one, 1/2 over square root of 3 halves, the twos cancel each other. This is 1 over square root of 3, and we've seen rationalization of that. If you multiply by square root of 3 over square root of 3, we have square root of 3 over number 3. So the rest of them are the reciprocals again. What is cosecant of power 6 or 30 degrees? Reciprocal of 1/2, 2. What about secant? Reciprocal of this, 2 over square root of 3, and we again have done this before, so times square root of 3 over square root of 3, and we get 2 square root of 3 over 3. So that's again pretty straightforward, everybody. And cotangent is the reciprocal of tangent. 3 over square root of 3, we should know it's square root of 3. In case you don't know, just multiply by square root of 3 over square root of 3. Hopefully everybody knows that already. So we showed how to find trigonometric values for power 6 or 30 degrees, 60 degrees, or power 3. So we can use them. Here's an application problem we can use. It says a rain gutter is to be constructed from a metal sheet of width 12 inches. So we have 12 inches. By bending up 1/3 of the sheet, 1/3 of 12 is 4. So we're going to bend it here, and we're going to bend it here to create this gutter. By bending up 1/3 of the sheet on each side through an angle of theta. So when we bring it up by an angle of theta, please understand these two lines are parallel. This is theta, so is this one. This is theta, so is this one. So we are using the same angle for both sides. Prove that the area A of the opening, this area, is given as A of theta is 16 sine theta parenthesis cosine theta plus 1, and then evaluate them. So that part is elementary. We just plug in. Let's look at how we prove this, reminding everybody, if you look at this shape, okay, it's a trapezoid. The area of a trapezoid as the formula 1/2 the height times B1 plus B2. Of course, this is inverted compared to what I have. So B1 is the smaller side, and B2 is the larger side. In some texts, of course, they use lowercase. They might use 1/2 h times lowercase b plus uppercase b. It doesn't matter. In any event, so now we are going to find, so we have the B1. In other words, this one is 4 inches. We also have this one to be 4, right? Now we want to find this distance, which by the way is the same as this one. And then this is the height. This is the height, everybody. So I'm going to erase my work. And again, this is theta, everybody. And if you look at this angle, sine theta and cosine theta, what are they equal to? Sine theta is the opposite. B, this is, they used B here instead of H, okay? The opposite. B over the hypotenuse. Please understand the hypotenuse is 4 inches, right? This is the hypotenuse, everybody, right? Cosine is the adjacent. We call this distance A. Over the hypotenuse 4 inches. Therefore, A is the product of these two, B is the product of these two. So let me erase all inks. So this becomes 4 cosine theta. This becomes 4 sine theta. So this height is 4 sine theta. This is 4 cosine theta, which means we have this side, lowercase b1 is 4 inches. Uppercase is this much, which is 4 plus this much and this much. There are two of them, 4 cosine theta and 4 cosine theta, and we have the height as 4 sine theta. So we're going to write B1 is 4. This is the smaller side. The larger side is 4, and 4 cosine theta plus 4 cosine theta, or 2 of those. And the height is 4 sine theta. So just plug in. So the area is 1/2 4 sine theta times all of those. 4 and 4 is 8. 4 cosine and 4 cosine is 8 cosine theta. Half of 4 is 2. So we get 2 sine theta times 8 plus 8 cosine theta. In fact, I can take the 8 out here. 8 times 2 is 16, and that's the proof. Now we plug in 30 degrees. So we proved this is right. Plug in 30 degrees. You know sine of 30 is 1/2. Cosine is square root of 3 over 2. 16 times 1/2 is 8. And you multiplied by square root of 3 over 2 becomes 4. Square root of 2 times 1 is 8. This is the exact answer, everybody. Exact. Roughly 14.93 inches squared. Theta is 45 degrees. Put it into that. When it's 45 degrees, 16 sine of 45 degrees, cosine of 45 degrees, and both of them are square root of 2 over 2. This cancels out this one, you get 8. And 8 square root of 2 times square root of 2 over 2 is 8. Times this 8 square root of 2. Exact again, put it into a calculator, 19.31 inches squared. I'm assuming nobody has any problem, multiplication of this. This is 8 square root of 2. And finally, 60 degrees, you plug in. Sine is square root of 2 over 2, and cosine is 1/2, which makes this one 3/2. Okay. The product of all of those gives us this exact answer of 12 square root of 3, or roughly 20.78 inches squared. So, in short, this is the most important part, proving this is the case. We've been over that. The rest of them we just plug in. All right, so for 30 degrees, 45 degrees, and 60 degrees, we should know the trigonometric functional value. And what we want to do, we want to find the exact values of a trigonometric functions for integer multiples of those. So, class, let's start with one of them. For example, pi over 4 is here. So square root of 2 over 2, square root of 2 over 2. So if you go with 3 pi over 4, x gets negated. That means cosine. But y is the same. If you go to the third quadrant, both of them get negated. That means sine and cosine are both negative. And if you go to the fourth quadrant, x or cosine remains the same, y becomes negative. If you work on a pi over 6, you can see the same strategy here. Fourth quadrant, x remains the same, y changes sign. Second quadrant, x becomes negative. In the third quadrant, both x and y become negative. The same thing happens with pi over 3. So the purpose of this is to make sure you understand. As long as you know the first quadrant, then you can easily figure out the other quadrant in the same manner. Okay, so again, both of them are positive. So if you go to the fourth quadrant, x remains positive, which means cosine, and y changes. Whereas here, x changes, becomes negative, y remains the same. And in the third quadrant, both become negative. So for example, if somebody asks you what is cosine of 5 pi over 4, you should know it's negative square root of 2 over 2. Cosine of 7 pi over 6 is minus square root of 3 over 2. So it's similar to pi over 6, but you have to figure out the sign, and that's the idea. And later on, we discussed this in the first quadrant. They are also known as reference arc. As long as you know the value for the reference arc, you can figure out the rest. Find the exact value for the following. 150 degrees. Please understand it's the same as 5 pi over 6. It's important to understand that. And so you locate that here, 5 pi over 6 or 150 degrees. You want cosine. Cosine is the x coordinate minus square root of 3 over 2. So this is the one. So again, I'm assuming everybody knows that and everybody can figure out the rest in the same manner if need be the drawing. But at some point, we really have to use the fact that the first quadrant, we have the information. So negative 30 degrees. So we find the 30 degrees and then the negative 30 degrees. This is pi over 6, everybody, the same as 30 degrees. So this is negative 30 degrees. So cosine is square root of 3 over 2. Sine is negative 1/2. Tan of 4 power 3. So this is 4 power 3. Cosine is negative 1/2. Sine is negative square root of 3 over 2. And so the ratio of sine over cosine. So this is negative 1/2. I thought I mentioned that, negative 1/2. Sine of negative power 6, negative 1/2. So 4 power 3 is this point, everybody. Here's the sine, here's the cosine, the ratio of this number to this number. As you know, negative cancel each other, 2's cancel out with me. Minus square root of 3 over minus 1 is positive square root of 3. And that shows that, by the way, in the first and the third quadrant tangent, and therefore cotangent, both of them are positive. What about 7 pi over 4? Let's locate a pi over 4. And then 7 pi over 4 is here, okay? Cosine is square root of 2 over 2. Sine is negative square root of 2 over 2 because we want sine negative square root of 2 over 2. So again, multiples of common arcs such as 30 degrees or pi over 6, 60 degrees or pi over 3 can be easily calculated. Use a calculator to approximate the value of. Well, use a calculator to approximate value of a trigonometric function. Your calculator has buttons for sine, cosine, and tangent. So to find values of the remaining three trigonometric functions, we use their reciprocal. So here's what we do. Cosine of 48 degrees, and it gives you many, many, many decimals. You answer it accordingly. Cosecant of 21 degrees. You put 1 over sine of 21 degrees. And again, the answer is with many, many, many decimals, 2.79 and so on. Tan of power 12. Tan of power 12. Make sure you change the mode to radians. This is degrees. Look at the mode of the calculator. So just so you know what's happening, if you have a graphing calculator, radians or degree, okay, we put it in radians, and then tan of power 12 with many, many decimals. Use a circle of radius r to evaluate the trigonometric functions. So we already know that x squared plus y squared equals 1, how to handle it. What happens if it's x squared plus y squared equals r squared? So not necessarily a unit circle. So P has coordinates x comma y. We are familiar with x squared plus y squared equals 1. What happens here? For an angle theta in standard position, let P be x comma y with a point on the terminal side of theta that is also on the circle of x squared plus y squared equals r squared. Then sine is y over r. Previously was the same thing, but r was 1, everybody. So it was y over r. Normally we go with a comma, if we go with a comma b, y is b. And cosine is x over r or a over r. Tangent is y over x as before, and the rest of them go with the reciprocals. So when x squared plus y squared equals r squared, the point has coordinates x comma y or a comma b. Sine is y over r, cosine is x over r, and the rest of them I would go with tangent being sine over cosine and so forth. It's very straightforward, everybody. So let's look at a very simple example. We want to find the exact value of the 6 trigonometric functions of a positive angle theta if 4 comma minus 3 is a point on its terminal side. So 4, negative 3, that's in the fourth quadrant. 4 comma negative 3, x squared plus y squared is 25. We can calculate that. 4 squared plus negative 3 squared plus x squared y squared. This becomes 16 plus 9, 25, and r becomes 5. And so we have a comma b or x comma y with coordinates 4, negative 3. So a is 4, b is negative 3. So r is the square root of a squared plus b squared, which we showed it's actually 5. So when the radius is no longer 1, you have to figure out the r as well. Remember, when you're dealing with the unit circle, you know r is 1. So it's not 1 here. Okay, big deal. So if you want sine is the y coordinate over r. So negative 3 over 5. Cosine is the x coordinate over r. So sine is b over r, negative 3 over 5. Cosine is a over r, 4 over 5. And sine is b over a. So basically negative 3 over 4. What about the rest of them? Reciprocals. So I want cosecant, the reciprocal of this, r over b or negative 5/3. I want secant, the reciprocal of this, 5 over r over a or 5 over 4. I want cotangent is a over b or the reciprocal of this, negative 4/3. So just the reciprocals, everybody. Find the exact value of each expression, which are multiples of power 4 or 45 degrees, reminding you of what we learned here as far as the unit circle. And if this is power 4, remember, this one, 3 power 4, this one, 5 power 4, this one is 7 power 4. And so we want cosine of 135 degrees. So 135 degrees is right here, or 3 power 4. So we are looking at this pair. If we are looking at this pair, cosine is the x coordinate. minus square root of 2 over 2. Tan of 3 pi over 4, same point, everybody. So how do you find the tangent? Sine over cosine, or y over x, which is -1. Sine of 225 degrees. 225 degrees. That's 5 pi over 4. 225 degrees, 5 pi over 4. Here's the coordinates. Sine and cosine are identical. Both of them are negative square root of 2 over 2. Cosine of negative 5 pi over 4. So from here, you want to go in the negative side, and you end up again here with these coordinates. Cosine is the x coordinate minus square root of 2 over 2. Sine of 9 pi over 4. I hope you recognize 8 pi over 4 as 2 pi, so it's a complete revolution, and then it goes back to pi over 4. So 9 pi over 4, maybe I should write this. This is the sum of 2 pi and pi over 4. So it's the same as pi over 4, which is square root of. So sine of 9 pi over 4 becomes square root of 2 over 2. What I want to add here is that what you do here is absolutely perfect. We use reference arc, okay? Use reference angle or arc. They use theta hat, theta sub r, or theta prime. And that means pi over 4 for all of these, pi over 4 is the reference arc. If we are in the first quadrant, reference arc and theta are the same. If we are in the second quadrant, so the reference arc is the closest angle that the terminal side makes with the x-axis, positive or negative, doesn't matter. So this angle, so what is this angle equal to? Pi minus theta. Pi minus theta would be, for this one, for this, theta sub r is here. For the third quadrant, this is the reference arc. So the closest angle to the x-axis, okay? And this is again pi over 4. So in this case would be the angle theta minus pi. In the fourth quadrant, this angle, which is again pi over 4, 45 degrees, so 2 pi minus the angle would be the reference arc. So using the reference arc, what happens? The value is identical to the reference arc. You just have to figure out the sign and whether it's positive or negative. So in this quadrant, you know x is negative, y is positive. In this case, both of them are negative. In this case, x is positive, y is negative. So using the reference arc makes it very easy to figure out the value. So the value is the same as the reference arc, either positive or negative.